Proving triangles similar. Review. Writing proportionality statements. In the diagram, triangle BTW is similar to triangle ETC. This is a symbol for similarity. So here is BTW, the big one, and then the small one is ETC. Write the statement of proportionality. When you write the statement of proportionality, you have to write in this format, 3 ratios equal to each other. So BT is equal to, corresponding to ET. They are proportional. This is the ratio. And then TW is proportional to TC. They're on the same side. And then WB is corresponding to CE. So you want to write the corresponding sides and make them equal to each other, their ratios, which is called scale factor. And then you're going to find angle TEC. So this angle is 79. So this angle TEC is 79 because you have 2 parallel lines. And this is the transversal. So they are corresponding, they're congruent. So if this is 79, that's going to be 79. Find ET and BE. So you're going to use the proportion. If it's 20 here, okay, the whole thing is 20. So right here you have 12 and 3. So if 12 and 3 is the ratio, you can see that the scale is 3 times 4 is 12. So this line is 4 times bigger than this line. So if this is 20, this will be 5 because 5 times 4 will be 20. Then this missing side is 15 because from T to B is 20. So 5 plus 15 is 20. So ET is 5, BE is 15. The scale factor is 4 to 1. Given the triangles are similar, solve for H. The ratio is 5 to 6. H over 8 because you want to know the bottom to the left side, bottom to the left side. The whole thing is 8, 6 plus 8. Cross multiply, 40 divided by 6 is 20 over 3. You can leave it as a fraction, and that is the H. You can also write as a decimal and round. So we're going to prove that triangles are similar. You can show that 2 triangles are similar by knowing the relationship between only 2 or 3 pairs of corresponding parts. Similarity tool number 1. AA. Angle-angle similarity postulate. So this is angle-angle. If 2 angles of one triangle are congruent to 2 angles of the other triangle, then triangles are similar. What does that mean? If angle A and angle D are congruent, angle B and angle E is congruent, then you can say that these 2 triangles are similar. So if 2 out of the 3 are congruent to each other, that's why it's AA, angle-angle, then you can conclude that these 2 triangles are similar. Same shape, different size. This is called angle-angle similarity postulate that we need to know. Side angle side. So side angle side similarity theorem is if the measures of 2 sides of a triangle are proportional to the measures of 2 corresponding sides of another triangle, then the angles between them, the sides, are congruent, then the triangles are similar. So this is how it looks like. If you have 5 and 10, 11 and 22, the scale factor is double. 5 times 2 is 10. 11 times 2 is 22. And the angle between these sides, so this is side, angle, side, side, angle, side. If they have a mark, that means they are congruent. Then you can conclude that these 2 triangles are similar. So you can write angle A and D are congruent. And then this is proportional. This is the statement of proportionality. So right here, AB to DE, they're corresponding. AC to DF, they're corresponding. Their ratio is the same. So that's 1 to 2 ratio. So it's going to be similar. So this is called side angle, side theorem. The next one is side similarity theorem. If the corresponding sides of two triangles are proportional, then the triangles are similar. So it looks like this. If you have 5, 10, 8, 16, 1, 11, 22, 5 times 2 is 10, 8 times 2 is 16, 11 times 2 is 22. They have same scale factor, same proportion. So you need to write this proportionality statement here. A, B to D, E, they are corresponding. Put it top to bottom. B, C to E, F, top to bottom. A, C to D, F, top to bottom. These are same proportion. They have same scale factor of 1 to 2. Then you can say, you can write the numbers like this, 5 to 10, 8 to 16, 11, 22, they're all 1 to 2. Then you can say side, they are similar because they have same proportion. So you can write this conclusion with the similarity symbol. Similar triangles and congruent triangles. Congruent triangles are a specific type of similar triangles. Therefore, all tools that we use to prove triangles congruent also work to prove them similar. The only difference is that now, instead of needing sides to be congruent, we need them to be proportional. What congruence tools did I not mention as similarity tools? Why not? We are not using angle, side, angle, angle, side. These are for congruent triangles. We're not using that because we have angle, angle. This is the tool number 1, angle, angle. When you have angle, angle like this for similarity, you don't need to use that. So, are they similar? Why or why not? We're going to look at these two shapes. These are triangles. This triangle and this triangle, here you have 33 and 32. You have 9 and 8, and you have 6, and then you have 90, 90. So if I subtract 90 plus 33 from 180, because triangle has 180 inside, this is 57. If I do 90 plus 32 and subtract from 180, this is 58. So the angles are not the same. So these are not similar figures, even though they look like it. So you need to prove by using the tools. These two, they have same angle, angle, angle. This is going to be 60 also, because 60, 60, 60 is 180. So they have angle, 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 similar, congruent. So they are similar triangles because of angle, angle theorem. Right here, if you subtract from 180, this is 31. If you subtract from 180, this is 47. So angles are not congruent here. Only thing that is same is 90 to 92. That is not enough. So you need to have another angle congruent in order to be similar, and it's not. So this one is no, this one's yes, this one is no. Are any of them similar? Why or why not? You have these three shapes here. Can you write A in this triangle, B in this triangle, C in this triangle? So which two are similar? So what you need to do is use statement of proportionality like this. So 6 right here, and then you have 9, which is right here, and then you have 4, and then 6, and then you have 8 and 12. They're gonna have 2 to 3 ratio here. Okay, so this triangle and this triangle, they have the same proportionality. So these two are similar triangles. If you look at A and B, 6, 6, 9, 10, they're not same ratio. This is 1 and this is 9 to 10. So these two are not going to work. So A and C are similar figures because they have same scale factor. Proving triangles similar. Steps for proving triangles similar. Number 1, identify and mark the given. So please mark them. Identify and mark any shear angles or vertical angles. Choose a method, angle, angle, side, or side, side, side. Think about what you need for the chosen method and be sure to include those parts in the proof. Proof number 1. We're going to prove that these two triangles are similar by using the tools. So here the given is D is parallel to GF. So write the given. Side DE is parallel to side FG. Write number 1, given. Number 2, we're going to write that when you have parallel lines, guys, you have alternate interior angles are congruent. So angle DF are congruent, angle E and G are congruent because here you have parallel lines and you have a transversal going through. So alternate interior angles are congruent. Therefore, this angle, same. This angle, same. Then you can use one of the tools for similarity, angle, angle. So the answer for number 3, you can prove that these two triangles are similar because of angle, angle theorem. So you have to write angle, angle similarity. This is just write the similarity symbol, theorem. Let's look at proof number 2. You have these two triangles. You need to prove that they are similar. So the given is right here. IJ equals 3NN, LN, JK equals 3NP, IK equals 3LP. What does that mean? That means this IJ is equal to 3 times this LN. These two are corresponding, same side. So the scale factor is 3 basically. JK is 3 times this NP. IK is 3 times this LP. So you need to write that proportion. I want you to write the statement of proportionality. So you do IJ divided by LN equals 3. JK divided by NP equals 3. IK divided by LP equals 3. Why? 3 is the scale factor. So you need to write the proportion corresponding. Match, match. These are matchy, matchy, same side. And then you just have to write that each one ratio for these, each one is 3, 3, 3 scale factor. So this is called division property equality because they have same number. When you divide, you get the same thing, 3, 3, 3. So that's the property that you use, division property. And then right here, we're going to use substitution. So you just write the statement of proportionality. So instead of 3, we're going to just write these. So you can write substitution or transitive. Because if this equals IJ equals 3LN, and then IJ divided by LN is 3, then IJ divided by LN, they have same ratio. You can write transitive or you can just write substitution. And then lastly, you can say, okay, in that case, they're all 3, 3, 3, 3, 3, 3 ratio, same scale factor, not same length. So they are similar. They're not congruent. They're same. Similar means same proportion. The corresponding signs are all same proportion, 3, 3, 3. So you can say that these two are similar because of side, side, side similarity. You can write the symbol like this, or you can write similarity at the end after the tool. So I want you to try proof number 3 by yourself. Make a chart and then try it. And I want you to pause the video now and check it when you're done. Pause the video and try the proof. Use one of the tools. Please check your answers. So we wrote the given, and then the base angles are here, F and H. These two are congruent, and these two are congruent because of this marking. And then we're going to write, if these two, F is congruent to H, and then J is congruent to L, then H and L is congruent, transitive, and then angle, 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 similar. So angle, angle, similarity is the way you prove because these two are same.